Okay, moving on with chapter 6 here, we're going to look at some trigonometric identities. So basically your trig version of proofs, but they're a lot more fun, at least in my opinion here. So the whole idea is we have to prove one side equal to the other. Okay, you can manipulate both sides, but you can't manipulate across the sides. So it's just kind of this idea, you know, two functions are said to be identically equal if f of x equals g of x. So we just have to basically prove left side equals right side. Here's what we're going to need to do all that stuff. Okay, you guys have these on your yellow sheet, and we've worked with them enough that we know these reciprocal identities. We're going to use a lot of those. Quotient identities, when you see tangents and cotangents, it's probably helpful to rewrite them as sines and cosines. These even-odd properties, I know we didn't stress them a lot. You may use them, you may not. Maybe some of the more difficult ones, you may have to do a little bit with this, but not too much. Again, where these guys come from is just simply this, like, you can only go one quadrant at a time is really the trick with these. So if you're trying to do sine of a negative angle, like let's say you're trying to do sine in negative 30, because that y value is negative, your sine will come out as a negative. Whereas if you try and do a cosine here, cosine of a negative angle, let's say you're trying to do cosine of negative 45, you're using still a positive x, so even though you are doing a negative angle, it still comes out positive. Okay. Same idea with the tangent. If you're going to do tangent of a negative angle, you're going to use that negative y, which is automatically going to make this thing negative. So I know we didn't stress those guys a bunch, but keep them in mind in case we do get to something that we have to use them for, and they are on your yellow sheets. Okay. So here's our first one. Okay, we're going to start off with some easy ones and then gradually work up over the next couple days to doing some pretty gnarly identities here. So you're going to see there's going to be two sides. One side's usually going to be more complicated than the other, and you basically have to get this side to equal the other side. Now, I could take a sine squared and I could rewrite it as 1 over a cosecant. You could use one of those trig identities. One of the trig identities we looked at that are also on your guys' yellow sheet, and this was your extra credit on the first test. So what I was, a little detour here, what I was looking more for on that extra credit was you can make these thetas. I'm not sure how they ended up as x's, okay? But if we take that unit circle, we know the radius is 1 on anything on the unit circle. Here's your cosine value, here's your sine value. If you square those, you will always get 1 because the unit circle there. Okay, so every value around the unit circle, sine squared plus cosine squared is 1. Where these other ones come from, and not everybody remembered it, which is fine, because we only looked at it for a little bit. If I take this original identity and I say, I'm going to divide by a sine squared, okay, that turns into 1 plus cosine over sine is a cotangent squared, and 1 over a sine squared is a cosecant squared. That's how we get that guy. Okay, you go back to the original again, and you divide by cosine squared instead of sine squared, and you will get this guy here. So those were those three come from. So we may be using those as well. Not so much today, but definitely on the second day of doing these identities. Okay, so keep those in mind. All right, back to this first one. So you could plug something in for sine squared. You could say, oh, well, I could take a sine squared and I could say a sine squared equals 1 minus a cosine squared. So you can manipulate these in a lot of different ways. Okay, but that's not going to do us any good. It's actually going to make it more complicated than simple. So I can only give you guys strategies here and suggestions with the different types of identities. It's just all a matter of practice, and if you're not getting it, trying something different. Okay? So one thing that's helpful is putting everything in terms of sine and cosine. So a cosecant is the same thing as 1 over a sine. Okay, notice I'm not going to do anything to that right side there. I'm trying to turn this left side into the right side. Sine over sine cancels, and I'm left with 1 minus a cosine squared. Now, I said we would be using that first identity a lot today. Okay, maybe so much not the other two. You can take any of these identities and move stuff to the other side. So if I want to get a sine squared, well, I can say it's 1 minus a cosine squared. If I want to get a cosine squared, it's 1 minus a sine squared. So I've basically just proven this right here. 1 minus a cosine squared equals a sine squared, and you have showed that these two guys are the same. Okay, but do make this last step here and check it against your identities, just so I know that you understand they're the same thing. Okay, so a simple one there, 1 step, 2 steps, and you're done. Let's look at this guy. Okay, so now you get some fractions with it. So cosine theta plus 1 over cosine theta minus 1, 1 plus a secant and 1 minus a secant. Okay. So when you see one of these guys here, it's tempting to think you can use one of those Pythagorean identities. Okay. You can go, oh, well, I got a cosine theta minus 1, so I can somehow go use one of these guys here. Okay, not the case. Okay, these are Pythagorean identities, meaning they're squared, and also the signs are backwards. So if you swing this guy to the other side, it's 1 minus cosine squared. This guy is cosine theta minus 1. Okay, so you can't really do that. Same thing with these guys over here on the right. You're like, oh, 1 and a secant. Well, I can go here. I can somehow do something with the secant, and if I move this 1 to the other side, it's a secant squared minus 1. Well, that's 1. That guy's a squared. This problem's not a squared, okay? And your signs are backwards, so watch out for those. Strategies for things with fractions. Common denominator, put everything in terms of sine and cosine. So I'm actually going to leave this side alone. I'm going to take this side right here and say this is 1 plus 1 over a cosine over 1 minus 1 over a cosine. Okay, so you get the fractions within fractions now. What I'm going to do is get rid of those fractions by multiplying every single piece by a cosine. Okay, so there's 4 different pieces here, so all of them have to get multiplied. Now, that cancels, and what happens, 1 times a cosine is a cosine plus 1, because we canceled up there. On the bottom here, 1 times a cosine is a cosine minus 1, and you are done. Okay, part 2, we'll look at a couple more different strategies.